All right, in the previous lesson, we looked at finding the inverse of a given function. This time, let's take a look at actually graphing the function and its inverse. Okay, so this was the previous example. F of x equals 5x minus 9, and then we calculated its inverse, and it was the 1/5 x plus 9 over 5. We're going to graph both of them. There it is. First, we're going to do it by hand, and then we're going to use Desmos to do the same thing, just because it's really helpful to have that skill. So the first function, the green one, was the original function. Okay, check the interval to make sure you understand what it is. It goes by 2, the y-axis as well as the x-axis. Notice 2, 4, 6, 8, 10. Okay, so it goes by 2. -9, right here. Remember that y equals mx plus b is your slope-intercept form, meaning the y-intercept is -9. So you plot that, -9, and then your rise over run, right here, rise over run is going to be 5/1, because the number in front of x, the so-called coefficient of x, is 5, and as a fraction that would be 5/1. So at the y-intercept you start -9, and then you go 5 up, 1 to the side. Pay attention to the interval, 5 up, 1 to the side. So it's kind of hard to do a really decent job since we end up being kind of in between the whole time. It makes it a little bit harder. So when that happens, guys, what you can do is you can find the x-intercept and make it a little bit more reliable, I want to say. So let's just recall how to do that. To find the x-intercept, we know that the y value must be 0, okay? Because that's the only way for a point to be on the x-axis, right? When y is 0. So our equation slash function was this. And when y is 0, I can now solve for x. And I would get +9 on both sides, just, use inverse operations to solve for x. And so happens it is 9/5, which is 1.8. Okay, so my x-intercept would be at 1.8. Again, interval was 2. So right before the first tick mark, 1.8 somewhere. Yeah, we did a pretty decent job. So let me go back to green so that we can actually keep our first given function green. So that would be the graph somewhat. Now, if you want to rely on your rise over run and you recall those little triangles, 5 up, 1 to the side, 5 up, 1 to the side, that will always be true. 5 up, 1 to the side. There you go. All right, so now the yellow. That would be the inverse. You got it. The inverse is what we need to now graph. 9/5 is 1.8. But of course, now that's your y-intercept. This one right here is your y-intercept, b. And it's going to be somewhere here. And now my slope is 1/5. 1 up, 5 to the side. Okay, again, I land somehow in between. Not fun. So it is really difficult to graph this way. As you notice, I can, of course, go 1 down and 5 to the left. That's possible as well. Or I can calculate the x-intercept again. So I'm going to do a bit of an approximation. Okay. Clearly, we would do a better job with a calculator, which is what we want to do. So, Desmos. If you go to Desmos, you can use the calculator option. And this is what it would look like. That was our first function. Let's see if we're close enough. Yeah, the green one. Not too bad. And this is our inverse. The blue one would be our inverse. Yeah, we did a pretty decent job. Okay. Now, I want to show you something that is quite interesting. Okay, when you have a function, which was in our case this one, 5x minus 9, and then you have the inverse, okay, the inverse of x, which is 1/5 x plus 9/5. You can always rely on one thing. Y equals x, the parent function of a linear function, as your mirror line. Okay, here we go, mirror. So in other words, if you use that as your mirror and you go from your original given function at a 90-degree down to your mirror and away from it, ding, ding, congruent, equidistant from the mirror line. So all points on the line, okay, all points on your function here will be equidistant, ding, ding, and can be actually graphed like this. You get the idea, equidistant. And you could make a graph that way as well. So that's kind of cool. Y equals x is your mirror line. And that's what it would look like in Desmos. Y equals x. Okay, so the first one was our function. The blue one was our inverse of the given function. Obviously, both of them are linear. The same is true for quadratic functions, by the way. Okay, you would do the same thing. Graph your original, graph the inverse, and y equals x would be your mirror line. So back to this example, f of x equals 5x minus 9 and its inverse. Today we learned how to graph a function and its inverse. We also connected to finding the x-intercept. Obviously, slope-intercept form, y equals mx plus b, locating the y-intercept, which will be your starting point when you graph. And once you have your y-intercept, consider the slope as rise over run. From the y-intercept, off you go. And then we finished with using Desmos and having both of your lines showing and recognizing that y equals x is your mirror line that mirrors the function and creates the inverse and vice versa.